The main question of all time goes like this: what was there before the Big Bang? The most common theory claims that about 13.7 billion years ago, before this incredible rapid expansion occurred, the universe existed as a singularity. It was a point tinier than a subatomic particle. At least, that's what the Big Bang theory tells us. Okay, but what was before that? This question has been bothering the minds of the greatest cosmologists for at least 1,600 years. For example, 4th century theologian St. Augustine was trying to figure out the answer to the question of what had existed before the universe was created. He made a conclusion that the phrase, "in the beginning," mentioned in the Bible, implied that nothing had existed before that. He also believed that time and the universe had been created simultaneously. The ancient Greeks were also bothered by the same question and kept debating the origin of time. Philosopher and scientist Aristotle, for instance, took the no-beginning side. He thought that nothing could come out of nothing. In other words, to get a universe, you need to have something for this universe to appear from. And since the universe couldn't have gone from nothingness to somethingness, it must have existed forever. That's why time must stretch eternally into the past and future. In the early 20th century, the world got to know about Albert Einstein's theory of general relativity. According to this theory, mass warps time, making it run a bit more slowly for, let's say, a human standing on Earth's surface and a satellite orbiting our planet. Based on Einstein's work, other ideas started to pop up, including the one that stated that the universe started as a singularity and expanded through the Big Bang. Then, quantum physics came into play. It gave birth to a bunch of new theories, which brought forth the questions about the pre-Big Bang universe again. And aren't these ideas fascinating? Some researchers believe that our universe is just an offspring of another much older universe. According to them, the evidence for this theory can be found in the cosmic microwave background, CMB, which is the relic radiation left over from the Big Bang. But let me explain. For the first time, astronomers observed the cosmic microwave background in 1965. At that time, they didn't know it would soon create problems for the Big Bang theory, challenging its ideas and postulates. Now, according to the inflation theory, an extremely rapid expansion of the universe occurred in the very first moments of its existence. This theory accounts for the changes in temperature and density in the CMB. It also claims that these fluctuations should be uniform. But recent mapping results show that the universe is actually lopsided. More fluctuations occur in some areas than in others. This makes some scientists believe that our universe bubbled off a parent universe. There's also a chaotic inflation theory, which takes this concept even further. It believes in an endless progression of bubbles, each eventually becoming a universe. And each of these appearing universes gives birth to even more bubbles, which results in an immeasurable multiverse. There are other models too. Some of them revolve around the pre-Big Bang singularity and black holes. If we think of these space monsters as cosmic trash compactors, they might end up being the main candidates for primordial compression. And our rapidly expanding universe could be a white hole output from a black hole dwelling in another universe. A white hole is a hypothetical object that acts in the opposite way to a black hole. Instead of pulling everything inside, it constantly gives off energy and matter. There's also the Big Bounce theory. Its main idea is that instead of going through one Big Bang, the universe expands and contracts in a cycle, bouncing back every time it shrinks to a certain size. Each cycle, therefore, begins with a tiny, smooth universe that gradually grows, becoming more warped with time. And eventually, it starts to collapse, smoothing itself out before starting anew. If you liked or disliked our video, put a like or dislikes. Leave comments. Let's discuss the mysteries of the universe together. And now don't leave, the video will continue.
Bang. That's how it all started, around 13.8 billion years ago, and was figured out over the past 100 years. Everything we see in space today, planets, asteroids, comets, stars, it wasn't there at the beginning. In the 1920s, astronomers came up with the idea of how a long time ago, the universe was just a single point. An extremely hot, like trillions of degrees hot, compact, dense point that stretched and expanded unimaginably fast. Matter that started flying in all directions at the speed of light at one particular moment. The Big Bang was complete chaos, with teeny-tiny particles that were mixed with energy and light. Yes, a total mess, but still, in the first minute after the Big Bang, the base for everything that would later appear was almost finished. It was hot only during this huge blast. As soon as the expansion started, the universe began to cool down, similar to when gas cools when you spray it from an aerosol can. During that process, part of the energy kinda froze out, just like the water freezes into ice. Here, pure energy got frozen and solidified into matter. 1 minute after the bang, the cooling thing was still going on, extremely fast and literally everywhere at once, since the universe really doesn't have edges. It wasn't just a compact dot anymore. The base for further expansion and all that's coming was being formed. Remember those tiny particles from that first boom stage of the universe? They started grouping together, which formed atoms of helium and hydrogen. It took about 3 minutes for most of the helium and all of the hydrogen in space to be made. These two are the most common elements and the basic materials that later formed the first galaxies and stars. Just because the base wasn't finished doesn't mean the creation of the universe stopped after those first couple of minutes. True, after that, no new elements were created for millions of years, which is why the initial version of the universe was entirely helium, hydrogen, and energy. But eventually, atoms began to slowly group together, which, after lots and lots of time, caused the creation of galaxies and stars. Clouds of helium and hydrogen grouped and turned into stars that had gravitational forces. Our Sun is also made of 3/4 hydrogen, while the rest is helium. 1/4? Yeah. At later stages, some other, heavier elements started to show up too, such as carbon, iron, oxygen, and so on. It wasn't all about chemical processes where new elements, stars, or planets kept coming. The whole universe has been expanding ever since the Big Bang. Researchers realized other galaxies are kind of moving away from ours. Guys, you need to stop doing that. How will we discover alien life out there if you keep running away all the time? And not just that. The farthest galaxies are actually moving quicker than the ones closer to our galaxy, the Milky Way. The universe is fabulous, unknown, mysterious, scary, and completely silent. Imagine yourself floating in your spacesuit somewhere above Earth. All you can actually hear is the sound of your own breathing, nothing from out there. Since there's no atmosphere, sound doesn't have a way to travel or be heard. Speaking of spacesuit, that thing costs around $12 million. I guess that means we'll have to wait up a little bit more to try that whole chilling in space thing. Mercury is the closest planet to the Sun, so you might think it's the hottest one too. And yet, Venus actually takes the title of the hottest planet in our solar system, with the surface baked by a temperature of 840 degrees Fahrenheit. Fair enough. Mercury doesn't have an atmosphere, which is in charge of regulating temperature, so it loses the race for the title of the hottie of the solar system. Venus also has pretty long days. Just one takes around 243 Earth days. Now that comes in handy for those people with pretty long to-do lists, who like to take it easy and slow. However, Venus orbits the Sun in 225 Earth days, which means 1 year there lasts 18 days less than a Venus day. You can have 2 birthdays in 1 day then? Well, 2 birthdays in a day could be one of the good sides, but the downside is that on Venus, it rains sulfuric acid and snows metal. Not so fun anymore, huh? The Earth is cool itself. Being 4.5 billion years old and the only known planet that supports life, it also has more trees than there are stars in the Milky Way. 3 trillion, while there are only 100 to 400 billion stars. We may have counted trees, but still, so little do we know about our ocean. Only 5% of it is explored, so we know less about it than about Mars or the Moon. whose surfaces have been fully mapped. It's funny how outer space is just 62 miles away from us, counting from above sea level on our planet. Seems so close, I sometimes go that distance just to have my breakfast. And yet, only 5% of the universe is visible from Earth. 68% of it is dark energy, while 27% is dark matter, which we can't see with a telescope. So close, yet so far. We will always see the same side of the moon no matter where we are on Earth. The moon rotates on its axis at the same speed it orbits the Earth. This is called synchronous rotation. Sunsets on Mars are blue. That happens because the fine dust on the red planet has the size perfect for blue light to efficiently penetrate the atmosphere of Mars. So the blue light scatters, after which it stays closer to the direction the sun goes, unlike the light of other colors. The universe is full of wonders, and one of them is a planet made of diamonds. Yay! It's twice bigger than the Earth, and scientists believe it's mostly covered in diamond and graphite. Now, to get there, you might probably need that $12 million spacesuit, together with a really expensive ship. But if, and that's the key word here, you manage to go there and back, you may even easily pay it off. Scientists also have some predictions as to the end of everything. Oh boy, ready for this? At its early stages, the whole universe was dense and compact, so it was really thick. But after around 400,000 years, it kept expanding, which made it more transparent. All of this encouraged releasing light we know today as the cosmic microwave background, or CMB. It's like if you turn your TV on an empty channel and switch off the cable, you'll see the static black and white dots moving on your screen. There's something like the CMB, and also an afterglow of all that energy that was released during the Big Bang. CMB is still here. Astronomers can see it through the microwave telescope. Expanding never actually stopped. The universe is still spreading every second at an unbelievable speed, causing all the objects in space to move away from each other all the time. How repelling! We know it because the sun from other galaxies appears redder than it's supposed to be. This is called redshift, and it happens when the source of light moves further from the one who's observing it. Then there's gravity. It attracts all objects in the universe to each other, which is the reason why planets keep orbiting the sun, or why our solar system orbits the center of the Milky Way. It's why we stay on the ground, while in space we'd float since there's no gravity up there. Having all this in mind, scientists got the idea that one day the universe will simply take the opposite direction and start shrinking back, which will be known as the Big Crunch. Whether this really happens depends on the type of our universe. If it's open, it'll keep expanding and nothing will ever stop it. But over time, as it's stretching, the density will become so low, galaxies won't be able to form new stars, and the existing ones will fade away. When space loses all the light and heat, life won't be possible. The universe will just remain as a cold beyond, which will keep spreading thinly into endless darkness. And then, Big Crunch or not, bang! It all disappears. Hey, good thing we have billions of years ahead of us, huh? Well, maybe you. I won't be around then. I'm going to retire.
Boom! It was an epic space explosion that made scientists' hair stand on end when they discovered it in February 2020. Its size and power are enormous, even by cosmic standards. We set our destination to a group of galaxies in the Giraffe constellation. If our rockets could fly at the speed of light, as fast as it takes the light from the bulb in your lamp to reach your eye when you switch it on, zoom, instant, it'd take 2.6 billion years to get where this explosion occurred in space. 2.6 billion years. A lot's happened in that time here on Earth. That long ago, dinosaurs weren't even around yet. Primordial life was just leaving the ocean and heading on land. Well, we're traveling faster than the speed of light, and we reach our destination, ground zero, for a boom so big it'd be like 600 million suns exploding simultaneously. And our sun is massive to begin with. It could fit 1 million Earths inside. In fact, 99.8% of the stuff that makes up our entire solar system is the sun alone. The remaining 0.2% is all the planets, moons, asteroids, and other random cosmic bodies floating around our star. And here's the real kicker. This burst lasted 100 million years. That's from today's digital world with smartphones and self-driving cars, all the way back to dinosaur times. So what set off this space boom of epic proportions? A black hole. What else? This monster swallowed so much substance that it choked and shot out a bunch of plasma beams. They cut through space and formed a cosmic wasteland all around the site. It was thought to be the biggest explosion in the universe. But sooner or later, every record gets broken. We head to another galaxy cluster. This one, dubbed Ophiuchus. An explosion thundered in it 5 times more powerful than the one in the giraffe. It was so big, you could easily line 15 Milky Ways across its blast area. Mind you, our galaxy is over 100,000 light years across and home to 200 billion stars. Yeah, whoa is right. It was the largest space blast since the Big Bang that started it all 13.8 billion years ago. So what was the source of this blast? To answer that, we'll need a simple analogy. Just like on Earth, space sort of has its own megacities. These New Yorks and Tokyos of the cosmos are massive, and that word doesn't even do it justice, but I tried. They're officially called superclusters of galaxies. At the center of the most mega huge ones, you'll find a supermassive black hole. Now, scientists still don't know much about them, but the theory goes that they're essentially a whole bunch of stuff, or matter, that gets squeezed into a teeny tiny point that can't even be measured because it's infinitely small. Yeah, complicated stuff. Think of it this way. It'd be like taking the entire Earth and shrinking it down to the size of a grain of rice. That grain of rice would still weigh the same as the planet. All that stuff would just be really squished together. So more matter equals more gravity, meaning a black hole's pull is unescapably strong. Not even light can get past it, hence the whole black part of its name. Funny thing is, we can't even see them with our eyes. Black holes don't glow or reflect light. They just swallow it up like spaghetti. Ugh, makes me hungry just thinking about it. But back to epic space things that go boom. A supermassive black hole exploded in this Ophiuchus supercluster of galaxies. This monster stopped pulling in everything around it like black holes usually do. Quite the opposite. It started spewing stuff out. A colossal stream of plasma ripped through space almost at the speed of light and broke through a bubble 1.5 million light years across. Every thousandth of a second, it was like 20 billion megatons of TNT went off, and it continued doing that for 240 million years. But now, I draw your attention to the heavyweight of the Milky Way. It's the toughest guy in the galaxy, a supermassive black hole called Sagittarius A*. The mass of this beast is 4 million times that of the Sun. And you'll like this, it's only 25,000 light years from our home planet. In space terms, this thing is pretty much like our neighbor 2 houses down the street. Wait, don't worry, no need to pack up and move. Our neighbor has given up his old business of shooting hot jets into space. But in 2019, he did make astronomers' hearts skip a beat. Near this Sagittarius A*, they noticed a flash that was 75 times higher than normal. Their theories: 1. The hole swallowed up part of a star that found itself wandering way too close for comfort. Or 2. A gas cloud crashed into it. After a 14-hour spike in activity, Sagittarius A* finally calmed down. Phew! But in the past, this giant was quick-tempered and knew how to light space up. 3.5 million years ago, our very ancient ancestors, as in they weren't technically human yet, were already walking across Africa, innocently unaware of a cataclysm happening far off in the sky above them. It looked like a beacon that suddenly turned on and shot out two cone-shaped beams. The whole thing was triggered by a hydrogen cloud 100,000 times more massive than the Sun. It came too close, and Sagittarius A star reacted. Those jets of plasma cut through space for 200,000 light years. They didn't stop for another 300,000 years. That's the snap of a finger on the cosmic scale, but astronomers still find traces of that boom even today. Neutron stars also know how to set off some fierce fireworks. They appear after giant stars run out of fuel and collapse in on themselves. Imagine the entire sun getting squished down into the size of a small city. Yep, that makes neutron stars incredibly dense and heavy. 1 teaspoon of their matter weighs around 10 million tons. They spin extremely fast, hundreds of full rotations a second. And for some of them, they shoot out energy beams from the poles, making it look like a cosmic lighthouse. One of the most interesting neutron stars is in the constellation Sagittarius. Like black holes, it has powerful gravity and pulls in tons of matter. This all collects in a massive rotating disk. This particular one was powered by hydrogen from a nearby star. It gulped up its neighbor, taking in so much matter that it started heating up. The result? A gigantic fireball launched from its surface. Astronomers witnessed this on August 20th, 2019. They saw a 20-second flash that lit up space. It was the brightest burst NASA has ever seen. The star spent more energy on it than the Sun produces in over a week. But of course, nothing beats the biggest boom of them all, the one that brought life to our entire universe, according to the most popular theory. But first, a little backstory. Scientists say only 5% of the universe is stars, planets, asteroids, comets, dust clouds, you, me, your chinchilla, all life, basically all the stuff you can see with your own eyes. So what can the remaining 95% be? The mysterious and dubious sounding dark energy and dark matter. In simple terms, they're like the yin and yang of space. Dark matter makes things attract to each other with gravity. It's the glue of our universe, keeping everything together. Dark energy does the opposite. It makes things repel and grow further apart. So the theory goes. And weirdly enough, dark energy makes things grow further apart the farther they are from each other. Scientists can even see this for themselves. The more distant a galaxy is, the more quickly it's moving away from Earth. But those two forces weren't always around. In fact, about 13.8 billion years ago, there wasn't anything around. Everything was condensed into a teeny tiny dot that's infinitely small. Sound familiar? Yep, this mysterious, forever shrinking point is also in the center of black holes, and it's called a singularity. It's where all our fancy science and math breaks down. It's the most puzzling thing out there. But one day, that incredibly dense and hot point started to expand in all directions, and it grew faster than the speed of light, doubling its size 100 times within a fraction of a second. If you want the specifics, it was 100th of a billionth of a trillionth of a second. Yeah. The more time passed, the faster and bigger it grew, and it's been expanding since, like blowing up a balloon that never pops. Scientists called this expansion the Big Bang.
Imagine a being so powerful it can suck in entire galaxies, so mysterious it's invisible to the naked eye, and so impressive it bends the very fabric of space and time to its will. Yes, meet my mother. Just kidding. Actually, meet the ultimate superhero of the universe, the black hole star. What is it and how does it work? Well, let's find out. The universe is full of marvels, and the black hole star is one of the most impressive ones. It's a supermassive force that can bend the laws of physics and a true enigma for scientists to unravel. No wonder science fiction writers find them so captivating. A black hole star, also known as a quasi-star, is a hypothetical type of extremely massive and luminous star that may have existed early in the history of the galaxy. They're predicted to be as luminous as a small galaxy. But unlike modern stars, They weren't powered by nuclear fusion in their cores. A quasi-star's energy would come from material falling into a black hole at its core. And yes, just like a normal black hole, these stars have the power to suck in anything and everything that gets too close, including stars, dust, and even entire galaxies. But how is it possible that the star is born from a black hole? And what's more, how do they continue to coexist together? Well, first let's discuss how black holes are born in general. It all starts with a supermassive star, one that is at least a few times more massive than our own Sun. This giant of a star burns bright and hot, shining with the light of 1,000,000 suns. But eventually, it runs out of fuel and its fate is sealed. As its lifespan comes to an end, it makes one final massive boom, a blast so powerful it can outshine an entire galaxy. This blast is called supernova. During this boom, the outer layers of the star fly away, while the core gets squished together by its own gravity. If the squished core is heavy enough, it can keep squishing until it becomes a black hole. And just like that, a black hole is born. Don't even try to put diapers on this thing. Now, this cosmic monster baby can continue to grow by swallowing up anything that comes too close, including stars, dust, and even entire galaxies. This is basically what's happening now in our universe with supermassive stars. But what about quasi-stars? The formation of a quasi-star could only happen early in the development of the universe, before hydrogen and helium were contaminated by heavier elements. And because of that, quasi-stars have one important feature. They are gigantic, so enormous that it's literally impossible to imagine. They may have been dwarfing even the largest known modern stars, like VY Canis Majoris and Stephenson 218. No wonder they're so scary. They were born from protostars, one of the first stars in the universe, the great-great-grandfathers of, everything. So now imagine a protostar so massive that its core collapses into a black hole, just like we described before. But the key difference is that in a regular supernova, the outer layers of the star are blown away by the energy released during the boom. Meanwhile, in a quasi-star, these outer layers are massive enough to absorb the energy without being blown away. What do we get in the end? A star with a black hole in its core that weighs from 1,000 to 10,000 solar masses. This quasi-star is about 14,000 times bigger than our Sun, which makes them bigger than any star we know today. These celestial titans have some pretty crazy properties. Once a black hole is formed at the center of a giant protostar, it starts to give off a ton of energy. This energy helps to balance out the force of gravity, making it kind of a giant fusion-based star. They would be so bright that each one would look like a small galaxy. Quasi-stars would have a pretty short lifespan, around 7 million years. Just for comparison, our Sun is about 4.5 billion years old, and it's only halfway through its lifetime. But either way, during this short period, the black hole at the center would grow to be about 1,000 to 10,000 times the size of our Sun. Quasi-stars are also thought to be super hot, with temperatures reaching over 17,500 degrees. But as a quasi-star gets older, it starts to cool down, and its outer layers become see-through. Eventually, it cools down to a temperature of 6,740 degrees, and at that point, it's curtains for the quasi-star. It can't survive at that temperature, so it just dissipates, leaving behind an intermediate mass black hole. Unfortunately, right now, there's no observational evidence for the existence of quasi-stars. This is because they're thought to have only existed a very, very long time ago. They may have been very massive population 3 stars, which are extremely rare and difficult to detect. It's also very unlikely that any of them would still exist today because of their super short lifespan, only 7 million years. So why do scientists believe that quasi-stars could have existed? Because they're looking for ways to explain how supermassive black holes formed so early in the history of the universe. They're found at the center of most galaxies. But how could these monsters have formed so quickly? After all, it takes a really long time for small black holes to grow into supermassive ones. This is where the idea of quasi-stars come in. These stars aren't just destructive forces of nature. They're like the black belts in the martial art of gravity. They can bend and twist anything to its will. That's why these stars, if they really existed, had to play a crucial role in the evolution of galaxies. They must have been instrumental in shaping the universe as we know it. So, those intermediate-sized black holes that they left behind could eventually turn into supermassive black holes in the center of galaxies. But we're still yet to solve this cosmic mystery. Detection and study of black hole stars is like trying to find a needle in a haystack. Only instead of a needle, it's an invisible and mysterious object. And instead of a haystack, it's the vast expanse of space. But with the help of some pretty cool technology and a lot of brainpower, scientists are getting closer to uncovering the secrets of these celestial giants. Here are some things that can help us in this research. First of all, gravitational waves. They're like ripples in the fabric of space-time, caused by the movement of massive objects. Albert Einstein predicted them way back in the 20th century, but they were finally detected only in 2015. We caught them by observing the collision of two black holes. This discovery confirmed that black holes can merge and that they're a powerful source of gravitational waves. Scientists think that by studying these waves, they can learn more about how black holes form and grow. We can also try to detect quasi-stars by observing the effects of their gravity on nearby objects. It's like trying to spot a criminal by their fingerprints. For example, if a black hole is located near a star, scientists can observe the star's light being distorted as it's pulled toward the black hole. And of course, we can use our technologies, such as X-ray, infrared, and radio telescopes. This allows us to study black holes in various ways and at different stages of their lives. In other words, scientists are working hard to uncover the secrets of these celestial giants. We develop new telescopes, search for primordial black holes, and try to understand the connection between black hole stars and dark matter. And we're making some pretty incredible discoveries, just like with gravitational waves. All these things will bring us closer to uncovering the secrets of quasi-stars. And when we find out the truth about them, it will become a new page in our scientific history.
Arcturus, a huge red star. It's just bursting from inside out. The red sea of plasma on its surface rages and pulsates. The star burns anything that comes close to it. And now, flop! Arcturus is gone. But at the same moment, it reappears at the center of our solar system, replacing the sun. What we see in the sky isn't a small yellow dot anymore, but a giant red ball. It's 25 times wider and 30% heavier than the sun. Even though Arcturus is a little cooler, it's still a total nightmare for Earth. The distance from our planet to the star is now 25 times less. All the water in the oceans and rivers begins to evaporate. What used to be rainforests are quickly turning into a lifeless desert. But sunsets and sunrises now look amazing. Imagine yourself on the roof of the Empire State Building, watching the sunrise. First, you see the light over the horizon. It almost blinds you because Arcturus is 110 times brighter than the sun. Then, the star gradually climbs over the surface. The thick dot on the horizon gets wider and wider. It continues to grow until the red star is everything you can see. Arcturus is now so close that you can even see storms of hot plasma on its surface. There are periodic outbursts and mass ejections. Huge amounts of matter are ejected from the surface of the star at speeds of up to 1,200 miles per second. The matter takes the form of a loop attached to the star at both ends. And you have to wear a super advanced spacesuit to be able to observe such a sunrise. Life on Earth ceased to exist long ago under these conditions, and it's going to get worse over time because every 8 days, Arcturus's brilliance increases, and soon our planet will become more like Venus. It's so close to the sun that the high temperature makes any life there impossible. Okay, let's let our planet cool down a bit and put Proxima Centauri in the center of our solar system. It's not a red giant, but a red dwarf. This star is almost 7 times smaller than the sun and almost 9 times lighter. Now our oceans and rivers are not evaporating, but freezing over. Forests and jungles are covered with snow. In about a week, there won't be a single place on Earth where the temperature is above freezing. Even plants that are used to the cold will cease to exist. They mostly feed on the sun's energy. Now, they begin to starve. But there will still be water deep beneath the ice layer. It'll be heated by the hot core of our planet. Microorganisms will still be able to survive. It's much darker on Earth too. It's like an endless twilight here. Oh, and we can barely see the moon. The thing is, it doesn't produce its own light, but reflects it from the bright sun. With Proxima Centauri instead, the moon will lose its brightness.
Hop on the bright side of life together with our brand new tees, hoodies, and more. Click the link to pick your choice.
But an even bigger problem would be with our orbit. The sun has a certain gravitational force, and it keeps us just in the sweet habitable zone, where we're not too hot and not too cold. Proxima Centauri's gravity is much weaker, and Earth is slowly drifting away from the star. We now run the risk of encountering asteroids flying through space, or even other planets. But the worst-case scenario is if Proxima Centauri simply can't hold our planet, and we fly away into dark space. Then, you can forget about any forms of life here. Now, let's put Sirius at the center of our solar system. It's the brightest star in our night sky. It's only 70% bigger than the sun, but almost twice as hot. So its glow is not only bright, it's sizzling. And its light is not yellow, but somewhere between blue and white. You couldn't go out in the city without sunglasses, or Sirius glasses. Still, you wouldn't want to walk the streets, where the asphalt is boiling anyway. You could literally fry eggs on the curb. Of course, by this time, all life on Earth has long since disappeared. But it's not just because of the temperature. Sirius emits enormous amounts of radiation. Our atmosphere serves as a shield against the sun. But in the case of Sirius, that shield wouldn't be enough. Now, why don't we take a more bizarre approach and make ourselves a double star system? These are two stars that revolve around a common center. And there's our Earth, safe and sound. It's all about the size and brightness of the stars. These two aren't too big, and they give off as much light as our sun. All that matters to us is that our planet is in the safe zone of the double star system. At sunrise, you first see one star appear from below the horizon, and then, a couple of minutes later, the other. The only problem is that this beauty may soon explode with enormous force. In binary systems, one star is always heavier than its companion. Sooner or later, it starts pulling matter away from the smaller star. Gradually, the bigger star just eats its neighbor. Then the big brother can reach a critical mass and explode. This explosion would be about as strong as a supernova. It would destroy our entire solar system. The light from this explosion would be visible for hundreds of light years away. And after that, there would be a huge nebula in the place of our star system. It's stardust and particles that are left from our world. Going to the realm of the crazy now, a black hole. Yes, there's one at the center of our solar system now. We know black holes are scary, mysterious objects that pull in everything in their path. But even around a black hole, there is a habitable zone. You just have to be far enough away so that it doesn't drag you down into its black abyss. Mercury and Venus would be too close to the black hole, so most likely they'd be torn apart and then head for the event horizon. This is the last stop before hitting the singularity, the heart of the black hole. There are only two problems: light and time. A black hole pulls light in instead of emitting it, so the Earth will quickly become dark and cold. And time goes slower around heavy objects. Near a black hole, 1 second can be equal to weeks or even months away in outer space. We won't feel this difference, but the entire universe around us will develop faster relative to us. Any object can become a black hole if it's compressed to a certain size. For example, the sun can become one if it's shrunk to a width of 3.7 miles. And even the Earth, if you squeeze it to a width of 0.7 inches, it becomes a black hole. Oh, Now there's some little rock lurking in the center of our solar system. It's a neutron star. It's about 18 miles wide. Some meteorites are much bigger than that, but it has a mass comparable to the Sun. So its gravitational force is about the same, and our planet's orbit is intact. But the problem is that neutron stars emit next to no visible light, so it's now permanent night on Earth. Still, it gets very hot here. When a neutron star is born, it can be several times hotter than the Sun at first, but it quickly cools down to the temperature we're used to. So there's a chance that all life on Earth hasn't yet been scorched. Another problem is that these little guys are rapidly spinning and can become pulsars. It's kind of like a powerful spotlight on two sides of a spinning star. Neutron stars also eject radiation at tremendous speeds. These rays will make our planet literally sterile. No life form would be able to exist under these conditions. And now, it's time for the biggest star ever known, Stephenson 218. This red giant is 2,150 times larger than the Sun. And if we place it at the center of our solar system, its edge will lie on Saturn's orbit. So Mercury, Venus, Earth, Mars, and Jupiter are already swallowed by the huge star. Saturn, Uranus, and Neptune are roasting like chestnuts on a fire and will soon evaporate. In fact, this could happen to our Sun as well. The older it gets, the redder and bigger it becomes. It'll eventually run out of its fuel, hydrogen, and the Sun will start to burn heavier elements in its core. This will cause it to expand. Then we'll see more beautiful sunsets and sunrises, but the temperature will become too high. In theory, the Sun will get so big that it'll swallow the Earth, and then it'll explode in a supernova, leaving nothing of our entire solar system behind. Shiny! Hop on board! Hurry, we don't have much time. We're on a cosmic journey to find the biggest star in the universe. The first star we pass is our own Sun. By far, not the biggest one out there, but it's still massive. You could fit 1 million Earths inside it. That means if you think of the Sun like a basketball, Earth would be half the size of a pencil eraser. If we put all the planets on one side of a scale and the Sun on the other, the planets wouldn't stand a chance. The Sun makes up 99.9% of all the mass in the entire solar system. Mass is basically how much stuff or matter something is made from, and it's what you can thank for stars shining. You see, the more matter in a star, the thicker and hotter its core becomes. This starts a chain of chemical reactions. Hydrogen atoms get smashed into each other to form helium, releasing an incredible amount of energy. That's the star's light and heat. So, bigger stars also equal brighter ones. But with all those reactions going on, this shortens a star's lifespan. When it starts to run out of fuel, the star will enter the giant phase. It'll expand and turn red. Which brings us back to the task at hand. The biggest star we'll find is likely to be on the edge of its life. Switching on our hyper light engines, we soon arrive at the Lumen 16 system. Here, we'll find one of the smallest stars out there, a brown dwarf. Small here means about the size of Jupiter, but they're small for stars. Brown dwarfs are also called failed stars because they don't have enough mass for those chemical reactions. That means they're not as bright, but they're super dense. All the matter in them is packed together so tightly, they weigh 80 times more than Jupiter, even being the same size. And if you think that's something, just look at a white dwarf, even more tightly packed. This one here is Sirius B. It's also about the size of Jupiter, but it'd weigh as much as the Sun. It emits a dim white light. Once it runs out of gas, it'll turn red and cool down. Now let's fly closer to its giant neighbor, Sirius A. You easily see this star from Earth, no telescope needed. Twice heavier and more than 1.5 times wider than our Sun, it's the brightest star in our night sky. Now we fly 550 light-years away from Earth to the constellation Cassiopeia. Almost 100 years ago, a cosmic explosion happened here. It expanded the atmosphere of the star Gamma Cassiopeia, and some gases were thrown into space. After that, it became the brightest star in the constellation. It's 10 times wider than our Sun. On to the famous North Star. Funny enough, different stars have had this title over the years, and more will take it in the future. That's because Earth's pole star changes every 26,000 years. Imagine our planet like a spinning top. The northern pole will shift around in a little circle, pointing at different stars to the true north. The current one is a supergiant 37 times wider and 5 times heavier than our Sun. It's easy to find in the night sky. It's on the very tip of the Little Dipper's handle. Get ready now. We're setting off for the eye of the storm, the center of our Milky Way galaxy. To see the next star, we need to switch to infrared mode. This pistol star is hiding from us in space dust. In just 20 seconds, it emits as much light as our home star does in an entire year. And its size is jaw-dropping. It's 420 times wider than the Sun. But it's still not the most luminous star known to humanity. That would be a blue supergiant in the constellation Triangulum. Meet B416. It's almost 10 million times brighter than the Sun. But the brighter a star, the faster it burns up all its fuel, and the shorter its life. Compared with a red dwarf that barely glows and burns fuel much more slowly, its life will be hundreds of thousands of times shorter. 3,400 light-years from Earth, there's one of the rarest celestial bodies in the universe. It's a yellow hypergiant called Rho Cassiopeia. Among the countless stars in our galaxy, there are only a couple dozen of these. And even though this star is extremely far away from our planet, you can still see it in the sky without needing a telescope. That's because it's 300,000 times brighter than our Sun. It also helps that the thing is 900 times wider than our home star, too. And its color tells us that its fuel reserves will last for a long time. When Rho Cassiopeia starts to turn red and expand, it'll be one of the biggest stars in the entire universe. Now, we move to the constellation Orion. The star is in our sights. Betelgeuse, one of the largest ones visible to the unaided eye. 700 times the size of our Sun. If it took our star's place, its surface would touch the asteroid belt. That's between the orbits of Jupiter and Mars. It would engulf the 4 inner planets, Earth included. But this star has astronomers very excited. They predict Betelgeuse will explode in a fantastic celestial show in the next 10,000 years. It'll be the greatest astronomical event of all time because we'll be able to observe a supernova at a close but safe enough distance. The exploding star will shine as bright as a half moon. It'll be visible in the daytime sky for a year and at night for several more. Now we venture to stars that exceed the Sun's width 1,000 times. Mu Cephei is a hypergiant boasting the title of the reddest known star. Its color tells us that the fuel gauge is getting closer and closer to empty. But it's still so big that it could hold 1 billion suns in it. And because of its mass, this star will eventually become a supernova or even a black hole. Let's take a trip of almost 4,000 light-years from home. Here it is, a red supergiant called VY Canis Majoris. It's one of the biggest and brightest stars of the Milky Way. It could fit 3 billion suns. And even though it's so huge, this thing is surprisingly light, only 17 weights of the Sun. In the context of celestial bodies, you could call this star an inflated balloon. In the next 100,000 years, VY Canis Majoris will explode in a hypernova. Gamma radiation will destroy all life in the local part of the universe. But this star is so far from our solar system that it wouldn't mean any harm to us. If we placed MY Cephei in the center of our solar system, it would bulge all the way out to Saturn's orbit. To remind you just how far away Saturn is, think of it this way. It takes the Sun's light 8 minutes to reach Earth. To get to Saturn, it takes well over an hour. Compared to this massive star, the Sun is just a grain of sand. It's one of the most luminous and reddest stars in our universe. The bigger and redder the star, the closer it is to its end. So, we're not looking at just a titan of the universe, but also one of the oldest celestial bodies out there. The second biggest star in the universe is UY Scuti. It's about 1.5 billion miles wide, 16 times the distance from the Earth to the Sun. This is a pulsating variable star. Its brightness changes about every 2 years. UY Scuti is a record breaker in fuel combustion per year. Scientists expect it to evolve back to hotter temperatures like a yellow giant. Our journey is coming to an end. Before us, we behold Stephenson 218. It takes 20,000 years for light from this star to reach Earth. It's hard not to see this red supergiant on our tiny terrestrial home. It's 2,150 times wider than our Sun. We'd need 10 billion suns to fill its volume. For comparison, the average beach contains only about 5 billion grains of sand.
Alarm tone and says, "Good morning. We're sorry to interrupt your program. Scientists have just discovered that the Earth's rotation has been fluctuating at an unusual rate. A group of specialists believe that the Earth is increasing its rotation with every second, and they don't know why. Even if the Earth increased its speed by 1 mile per hour, the day would only get shorter by a minute and a half or so. We wouldn't really feel it, and you could go on like nothing is happening. But as the Earth spins faster, our bodies, which are adjusted to a 24-hour timing, will have a hard time trying to cope with it. If you live by the equator, that means the rotation of the Earth is going quicker than at the North and South Pole. The area by the equator needs more time in order to complete its full rotation from the starting point. You'll experience more rain than usual. The Earth's rotation keeps the weather consistent and balanced so that nothing abnormal happens. But because the Earth is moving so fast, the weather is acting up. We'll start to see more storms and more cozy days inside, sipping on hot cocoa. Even though it seems weird, everyone can go about their day. But if the Earth picked up some speed and moved at 150 feet per second, the day would be reduced to only 22 hours. It kind of makes you feel jet-lagged 24/7. Every business works with the 24 hours a day schedule, so taking away even 2 hours can have catastrophic effects on the world economy. The whole calendar will have to change and adjust to the new timing. Clock designs will change with the new midnight, replaced with 10 o'clock. And with each week, the hours will shorten, so there will be no proper way of telling time except by sunsets and sunrises. The weather will continue to get worse and worse, feeling like the rain will never stop. The animals that rely on weather patterns won't know how to function, and mass migrations will occur from almost all species of animals. Flocks of birds will be flying everywhere and reach places they normally won't go to, affecting the whole food chain and ecology. Woods, jungles, and other places where animals roam are kept in proper balance when unaffected by humans. If it constantly rains in certain areas, then floods will force animals to move to other territories and compete with the predators in the area. If the Earth picked up speed every day, then standing on a scale in the Arctic would tell you weigh 180 pounds. But around the equator, you might weigh about 179 pounds. That's because of the extra force opposing gravity in that area. With the Earth spinning faster, all airlines around the world stop, since the radar systems have gone haywire and the weather is too dangerous to fly. Everyone has to get around by car. Satellites are positioned in such a way that it's crucial they remain where they are in order to bounce signals to us. Because of what's happening, Wi-Fi and TV signals can't go through. Communications around the world will end up short and slow, and eventually we'll have a total communication blackout. Ships will cease to operate and global trading will collapse, adding extra damage to the already failing world economy. Winds will get stronger and faster than usual, which means temperatures will change. Storms like hurricanes will be stronger than ever and have more energy for destruction. And still, at 100 miles per hour, the equator will now be swallowed up in the water. The Amazon basin and small islands will now completely submerge in water by around 50 feet. Most of the plant life will be in danger, especially by the equator. With woods threatened by floods, more animal environments will be in jeopardy. The trees and plants won't survive so much flooding. If the Earth rotated so fast that the hours would now be reduced to 15, then we'd probably feel like we're always on a jet plane going through turbulence. It would be impossible to sleep if the Earth kept picking up speed every second of the day. So days would be around 7 hours long as well as nights. The whole world would be flooded, except for the highest points and the tallest mountains. If that happens, humans will most likely end up there clinging to the last remaining clear patches of land. Most of the animal life will be extinct as well. And as the Earth is spinning faster and faster, the crust will lose its durability, allowing more frequent and stronger earthquakes to happen. Volcanoes will erupt all over, even if they're submerged in water. It'll go on like this for quite a while. Many major natural disasters like earthquakes, tsunamis, volcanoes, and even melting ice sheets have sped up the speed of the Earth by milliseconds. So, with the Earth's continuing speed increasing, these natural disasters will make the planet go even faster. Even if it's just for milliseconds, it's enough to have major consequences. The Earth is now spinning at 1,000 miles per hour, and as you're sitting with the rest of the survivors, you feel yourself levitating slightly. You'll see tiny pebbles and rocks floating inches from the ground. The clouds above you are passing like shooting stars. The air is thick with moisture, since water is rising to the top, forming thick clouds ready to pour. But since gravity is weaker, some of the rain is suspended in the air. Many small objects will be floating around as if you were in space. The days and nights won't be longer than a few hours. At this point, the whole world will be flooded, and the crust will be 80% gone. If it goes on any longer, there won't be any living things around, probably except for microscopic creatures that can withstand extreme and harsh conditions. The Earth would need to spin at approximately 17,600 miles per hour to cancel out the gravity for things to start floating around. At this point, all the water in the ocean will rise and look like reverse rain. The large mountain rocks will separate from the bedrock and levitate above the ground, looking like little planets in space. The Earth is now spinning 17 times faster than usual, which makes one full rotation around its axis only 84 minutes instead of 24 hours. If you manage to stay that long, then you'll literally see the days and nights go by in an instant. You'll also be floating aimlessly in the sky, bumping into rocks and other surfaces. You won't recognize anything anymore. The Earth's crust is ripping apart, exposing the magma underneath. So landing on the ground isn't an option. You'll see outer space as you go higher and higher. You won't know how fast you're going, but all you know is that you're probably the only human left in this spinning world. The Earth will eventually spin so fast that the rest of the layers will start to peel off, exposing the Earth's interior. It'll start to squeeze itself from the core until it becomes similar to a pancake. Nothing can survive at this point. So much heat will be produced from the core that the planet will heat up like a microwave. All the water will disappear, and it'll look like a red dot in the solar system. And once it starts to approach the speed of light, time will freeze. The rocks and floating elements won't move and will eventually be distorted. And with enough effort, the Earth will eventually turn into a black hole. Of course, nothing like this will ever happen. According to scientists, Earth will most likely slow down in rotation. Ever since the Moon came into the picture, the Earth has been slowing down by around 4 miles per hour every 10 million years or so. That's because of the Moon's gravitational pull on our little blue planet. It'll most likely go on that way.
You're sitting in the car, waiting for the traffic light to turn green. The temperature's so high today it seems the city is about to melt. You look at the traffic light and notice it's deforming. Drops are dripping down from it. You don't believe this is really happening, so you're rubbing your eyes with your palms and you find your silver ring is slowly flowing down your finger. You scream in fear because you expect the molten metal to scorch your skin, but nothing happens. The traffic light completely drains down. You want to press the gas pedal, but there's only some kind of liquid under your feet. The seat belt unfastens itself, and the car slowly sags. You open the door, and it falls off. You run out of the car and watch it slowly melt. The wheels, the blue body, the internal details, the motor, everything turns into liquid. Only the tires, plastic things, seats, car carpets, and glass remain intact. You hear screams behind you, and you see all the other cars around are melting. You want to record it on video, but your phone has become liquid too. You take out the remaining glass screen in the plastic case. All the metals around are melting. Street lamps and bus stops turn into a homogeneous mass. Suddenly, it gets completely silent. Car horns, the noise from the highway, sirens, exhaust fumes, and engine roars. All of it has disappeared. Rivers of liquid metal are flowing down the streets, and you're in the center of this. The metal stream carries away the tires and other car details. It knocks people down. Then, a low, loud noise sounds through the city. People are running out of malls, libraries, cafes, homes, business centers. Puddles form around all houses. Every building is equipped with metal structures, rebars, and fittings. Now it's all melting and seeping through the concrete. Metals are melting slowly, so people have time to evacuate from the city. All the buildings are collapsing and raising dust in the air. Sewerage hatchways are flowing downwards. The city's sewer system is melting. Water mixed with liquid metal comes out on the streets. People are swimming in this mass. They're using hundreds of thousands of rubber tires as life buoys. Someone's even riding a surfboard. Liquid coins are flowing out of your wallet. Hundreds of ATMs around the city are melting. Millions of paper banknotes are drowning in metal flows. All the gold reserves become liquid and paint the city with an orange color. Thousands of letters float on melting mailboxes. All data centers, computers, and servers become a part of the huge metal stream. Instantly, all the digital information in the world disappears. Televisions, game consoles, amusement theme parks are melting. Radio receivers, telephones, electrical wires, cables, and internet connections disappear. Millions of tons of metal fill in the street, then pour into rivers and oceans. The water is getting a dark silver shade. In one day, people lose all modern technologies and return to the Stone Age. Metal rivers flood cities. People run to the countryside. Bicycles, motorcycles, and other forms of transportation are gone. City residents are deprived of electricity and all things that are powered by electricity. It's not safe to be in a natural area either. Metals are hidden in the mountains and underground. Now they turn into liquid and cause deformation inside the soil and stone. Some mountains are ruined, like a melting hill of ice cream. Earthquakes shake the ground all over the world. Seismic activity wakes up volcanoes. They splash out a huge amount of lava and cover the sky with ash. Volcanic magma contains a lot of molten metals, but now they don't solidify. Pools of cold lava are formed around volcanoes. People learn to live anew in such conditions. They build houses out of plastic and wood, using ropes and glue to connect the materials. You can now easily start a fire with wood and stone. People burn glass to make it stronger. They make axes and other tools from high-strength glass and stone. But such items quickly deteriorate and break. You learn how to build dugouts. You drip the soil and use wooden boards to support the ceilings and walls. Almost the entire population of the planet lives underground, since it helps keep warm during winter. But it's not possible to live like this for a long time because of frequent earthquakes. Wooden chariots appear on the roads again. Problems with the harvest begin. Metals seep into the soil, and this disrupts the growth of the crops. Many people live near the ocean. During earthquakes, they get on wooden rafts or inflatable boats and sail away from the shore. To travel long distances, people fly in balloons. You can even get to a neighboring city if the wind doesn't take you away. It's impossible to send a letter to another country since there's no more railways. People make long walking journeys and live like nomads. You use pigeon mail to communicate with friends living in the neighboring city. It's difficult to get food and live in winter without electricity. But there is hope. Scientists can't find out the reason for the change of metals without technical equipment, but they put forward the theory that metals have changed at the molecular level. The molecules moved away from each other, and this caused melting. To bring everything back, you need to connect the metal molecules closer to each other, and people need an electric current for this. Fortunately, there's enough of it in the sky. Every day, lightning flashes somewhere. You just need to catch it. Scientists create plastic containers and fill them with liquid metal. All containers are connected by a rubber wire with molten copper inside. Copper is one of the best conductive metals. On a huge field, people place hundreds of such containers. Clouds are gathering. A strong storm begins. The lightning strikes the ground several times and finally hits the container. It comes through a copper wire and distributes the charge to all other tanks. A chain reaction begins. When the storm ends, people discover containers with solid metal. It worked! Now we have a couple of tons of ordinary metals. Scientists send mail pigeons to spread the news. Soon, people around the world are trying to catch the lightning. The resulting metals are enough to build minimal equipment for a power plant. Scientists use electricity from power plants to turn metals into powerful magnets. Liquid iron, copper, and aluminum seep deep into the ground and the ocean. To get them out of there, people build metal mining stations. First, they make a deep hole in the ground, then lower a huge magnet there. Liquid metals pass through the soil and stick to the magnet. People use the extracted materials to build new magnetic stations. They install them all over the world. Huge magnets appear in the seas, rivers, and oceans. People pump all the liquid metal out of the water and make it solid with an electric charge. Then, people create metal tools, axes, saws, machine tools, anvils, spokes, and wheels. Then, they make metal fittings and frames for houses. Life is slowly improving. People make chains, bicycles, and rebuild factories. They restore railways and launch the first trains. A new industrial era has come again. Iron, nickel, and aluminum are more expensive than gold because of a huge demand for them. Also, separating liquid copper from liquid silver and other metal separating operations is a difficult task. This increases the price too. When solid metals become abundant, their price begins to fall. Previously, to get iron, people dug deep quarries and mines where they extracted iron ore. Now, metals are liquid, and they attract themselves thanks to magnetic forces. You can stick a long magnet in the ground in your backyard, and the next day, it will be covered with iron. Easy metal mining accelerates technological growth. Now you don't need furnaces to melt steel or silver. You immediately get them in liquid form. You can pour metals into a jar and store them forever in liquid form. And an electric charge can make them solid. The first planes and ships appear. The international export and import of goods are fully restored. But the fastest thing people restored is power lines in the internet. In 1 century, humanity has managed to completely rebuild modern technologies.
The speed of light is the fastest thing in our universe. It travels across space, passing through Mercury and Venus to reach us, and it's slowing down. No need to panic though. The sun is getting weaker, but we won't see the effects of it for another billion years. In the vacuum of space, the speed of light is around 186,280 miles per second. Any slower than that, and humans would see the changes firsthand. There would be some awesome effects, like colors changing and the brightness of objects fading. We'd also notice some differences in everyday objects, their length and shape. Scientists created a simulation to see what would happen if the speed of light was slower. In a vacuum, the speed of light can't change. But if light passes through different materials and objects, it alters the way we perceive things. Light acts as a wave and a particle, meaning that it's a wavelength. The color and frequency are determined by the distance from crest to crest in the wave. It behaves similar to sound with the Doppler effect. Imagine you're standing in the middle of a busy highway and a honking car speeds through. Wow, that was loud. You can hear that whoosh-like sound of the horn because the moving object produces the sound while you're stationary. The frequency and pitch seem to change, but it's just the sound reaching your ear faster than it would if you and the car were both stationary. Light behaves similarly. The wavelengths change if the speed changes. Moving toward a light source and making the wavelength shorter will shift the color to a blue and violet hue. Moving away from the light source, and you'll get something more reddish. So if the speed of light slowed down to walking speed, we'd notice the colors changing when we approach an illuminated object. At the same time, the color would change around us and behind us. If you walk sideways, the colors you're walking toward would become bluer, and everything in the distance would become red. This information is useful to astronomers who are studying objects in space. If they're blue shifted, that means the object is moving towards us. And if it's red shifted, then it's going in the opposite direction. In fact, everything in the universe is red shifted, proving that the universe is expanding and getting further away from us. The slower it gets, the brighter it becomes. That's because the photons become more present for us to see. At this rate, we can see invisible light and increased intensity. You won't notice that effect much if you're standing still, but because of the Doppler effect, moving towards an object will have different colors and different light intensities. Another phenomenon we'd experience is time dilation. It's when you move at a similar speed as light and time decreases relative to someone who isn't. Space and time are relative. So if you're sitting at your desk wasting hours away, yeah, sounds familiar, doesn't it? All your movement will go through time and not through space. You're stationary, but you're still technically moving forward in time, slowly aging. The faster you move through space, the slower your movement through time will be. If you move at the same speed as light, then all your movement will be through space and not through time. To notice that, you'd need another person to watch you. You're not in a time machine. You're both on Earth experiencing the same time flow. To you, experiencing this firsthand makes it feel like you're going faster because you're getting a lot more movement in space in a given time. The closer you get to the speed of light, the smaller you become. Well, not really, but it depends on who's watching. If you're the one traveling at such a speed, an object nearby will seem small, just as someone who's watching you travel at the speed of light will think that you're smaller than you actually are. The simulation that the MIT scientists conducted showed that if the speed of light drops, everything will become stretched out like a pancake. If you see mountains in the distance and then run at the speed of light, they will appear further away. Objects will become distorted, and it will feel like you're getting to a certain place faster because time has slowed down for you. If you're standing completely still and someone standing on your left-hand side throws a cube-shaped object over to your right-hand side, then naturally, you'll see one side of it unless it flips around. But in this new reality, you'll get to see the front side wrapping around the visible side you're seeing. If you're moving at the same speed as light in an infinite space, everything will be stretched out as you reach infinite speeds. In a world where people can walk at the same speed as light, we'll perceive nothing as normal. We'll have to get used to the way we see objects. Every movement we make will result in drastic shifts of colors. Even turning your head to look at something will feel weird. Let's say you're in a supermarket buying groceries, and you walk from aisle to aisle. The milk at the end of the counter will look like it's really close to you. But when you approach it, you'll start to feel like it's getting further away from you. The milk will also look a bit red. As soon as you get closer to it, it will shift to blue. If someone is passing through with a shopping cart, you'll see it as a sort of 3D model of a shopping cart. The color will shift as it gets further away from you. It will appear far away, but it's right in front of you. In fact, we don't really know the actual speed of light. Physicists gave it roughly 186,280 miles per second, but that constant is just for them to calculate other scientific stuff so we can understand it better. The problem is that we can only measure light with light beams and mirrors. But it's not like all we have to do is point a light beam at a mirror and measure its original path and its reflected path. Einstein's theory of relativity states that the original path of light moving from the source to the mirror may not be the same speed as the reflected light from the mirror back to the source. Hypothetically, if it takes light 10 seconds to travel from the source to the mirror and then back to the source, then we can conclude that each trip takes 5 seconds. But Einstein's theory is that it could take 9 seconds for light to travel from the source to the mirror and only 1 second from the mirror back to the source, or vice versa, or maybe completely different numbers altogether. That's why it's so difficult to measure light. A breakthrough came out for scientists when they managed to slow down the speed of light to 0 without losing its brightness. They did this by using ultra-cold atom clouds made with photonic crystals. These crystals are materials punctured with billions of tiny holes where light can refract. But what if we lived in a world where light stopped halfway? You'd wake up one morning and feel like it's twilight. You'd open the curtains and see that many car lights are on but aren't so bright. You turn on the lights in your room but feel like the bulb is tapping out. You replace it with another one, but it doesn't do the trick. You turn on the lights everywhere in your house, but it's all just giving weak light. You're confused and try to check if there's a problem with the electricity in your house, but it seems to be working well. You check on your neighbors, and they also have the same problems. Even experts in the field can't understand what's going on. Hours pass, and it's all the same. All the light in the world seems to have frozen halfway. Your phone is low on brightness, even though you bumped it up to maximum. Everything is getting darker. You learn from the news that it's a global problem. Light is slowly diminishing, and soon there won't be any of it in the world. You decide to wait it out while everyone else is panicking.
In the past 30 years, scientists have made an incredible discovery of a new creature living deep beneath the surface of the ocean. And the name of the creature is the harp sponge. Now, if you're wondering why it took so long to come across this animal, then I might have the answer. These creatures typically hang out at a depth of roughly 11,100 feet beneath the ocean's waves. This sponge species was first discovered off the coast of California thanks to a robot that was sturdy enough to explore those crazy depths the ocean has to offer. This is no doubt an area of the planet where even the most benign-looking creatures can be potentially dangerous. But even scientists were surprised to find that this creature was more than just a sponge. Now, this might seem obvious, but the harp sponge got its name because its basic structure, referred to as a vein, is the same shape as a harp. Each vein is made up of a horizontal branch supporting several parallel vertical branches. But don't let the harp sponge's fanciful and amusing appearance or its non-intimidating name fool you. Yeah, the harp sponge is very much a deep-sea hunter. It has a unique ability to capture and envelop small animals using its rhizoids, short, thin fibers. With their help, the harp sponge clings on to the soft, muddy bottom and catches tiny creatures that get swept into its branches by deep-sea currents. Uh-oh. Other sponge creatures often feed by pulling bacteria and bits of organic matter from the seawater and filtering them through their bodies. But not our harp sponge. Instead, it snatches its future meal with minuscule barbed hooks that cover each of the harp sponge's branches. Now, harp sponges prefer tiny crustaceans like crabs, crayfish, shrimps, and prawns. Once the harp sponge has one of them in its clutches, it envelops the animal in a thin membrane before slowly beginning to digest it. So, pal, what's eating you? Oh, Harpo? Too bad. Researchers believe that harp sponges use this method of feeding because there aren't enough nutrients that deep down. This makes traditional filter feeding less effective. Research has shown that the creature is still in the process of evolving. Early harp sponges, researchers found, only had 2 veins, but later, scientists discovered other harp sponges that had 6 veins. The harp sponge might have evolved this elaborate candle holder-like structure to increase its surface area. In general, harp sponges typically grow up to a length of 1 foot, but researchers have seen a creature that was 2 feet in length. The harp sponge is not only very unusual, but also beautiful to look at. See those tiny white balls on top of the branches? Now, why don't we look at some other creatures that live below the photic zone of Earth's oceans? The photic zone means the area beneath the ocean's surface that still receives some sunlight. Thanks to this, there are loads of different creatures and organisms living there. Any animal living beyond this layer qualifies as a deep-sea creature. The Tomopterus worm is a segmented worm you can find in the twilight zone of the ocean. This is the area that lies between 650 and 3,300 feet beneath the surface. These creatures are often no more than 1 inch long, but the largest of them can grow up to 1 foot. While swimming around and feeding, these worms do what researchers describe as an amazing smooth dance. That's because the creatures can swim extremely quickly and maneuver at tight angles with ease. Now, I know most people hear the word worm and think of the common earthworm, so it's quite interesting to know there's a deep-sea worm out there that never leaves the water during its entire life. Similarly, most of us try to avoid jellyfish that either rest on the sand or sit on top of the ocean waves. This isn't the case with a chrysota jelly. That's a deep-sea creature too. This beautiful jellyfish is mostly ruby red, bright orange, or electric purple. That's what helped researchers realize they had found a new species of jellyfish. The creature grows to a maximum size of 1 inch across. It has tentacles that stretch out in every direction. Now, if you come close to this jellyfish, it'll pull all these tentacles in toward its body before rapidly swimming away to avoid danger. Yes, you are dangerous. The Chrysota jelly is extremely rare. You won't see it very often. You might need to borrow that deep-sea diving robot I mentioned earlier. While worms and jellyfish might seem quite harmless, this isn't the case with the Pacific viperfish. Ooh. This creature is equipped with a noticeably big mouth, like me. And the needle-like teeth inside are key to its hunting strategy. Pacific viperfish live at around 5,000 feet below the ocean surface. But they're among those numerous marine animals that migrate each night from the ocean depths toward shallower waters to dine. What's on the menu for dinner tonight? Lots of small fish and shrimp. The creature can grow up to 12 inches in length. Its two front fangs, which stick up from the fish's bottom jaw past its own eyes, are especially dramatic. When the fish unhinges its jaw, its mouth can open wide enough to engulf smaller animals, and the teeth form a cage to prevent an escape. Now, have you ever seen an underwater creature that looks like a strawberry? Trust me, it does exist. Just look at these dots on the strawberry squid. The creature has a big eye and a smaller one. You might think this unconventional pairing would be awkward and uncomfortable, but it's actually the opposite. The big left eye looks upward. It spots shadows cast by other animals in the dimly lit waters above. The eye's tubular shape helps it collect as much light as possible. On the other side of the squid's head, you can see its right eye. It's small and looks downward. This eye searches for flashes of bioluminescence produced by animals lurking in the darker waters below. Now, bioluminescence means the production and emission of light by living organisms. By the way, the squid has a nickname. And no, it's not Squiggy, although that's a great one. It's known as the cockeyed squid. This is simply due to the remarkable difference in size between its two eyes. I think I like Squiggy better, and so it goes. Since light doesn't reach the deep sea, the strawberry squid's body actually looks black. This helps the creature hide from enemies, such as sharks and dolphins. In general, the strawberry squid grows to a length of 5 inches. It typically lives around 3,000 feet below the surface, but floats to shallower waters at night. Now, the feather star is a marine creature without a backbone, but with feather-like arms that radiate from the center of its body. These creatures first appeared around 200 million years ago. Related to sea stars, they look like a flower, but if you approach them, they'll quickly swim away. But not all feather stars can swim. Many species can only crawl along the bottom of the seafloor. Like some of the other deep-sea creatures we've looked at, the feather star can adapt to its surroundings. It has a creepy ability to shed its arms, the same way some lizards can shed their tails. This also helps them escape from their enemies. Feather stars live all across the globe, from the equator to the poles, from the shallow waters on top of reefs to the deep, deep sea. Now, given that we're dealing with mysterious creatures, the name of this one is quite fitting. The swift vampire squid should be the official symbol of life in the deep sea. The animal has a dark red body, huge blue eyes, and a cloak-like web that stretches between its 8 arms. This, along with its name, may suggest that the creature is some form of a terrifying hunter. In reality, though, the vampire squid is a soft-bodied, timid creature, about the size, shape, and color of a football. It grows to roughly 12 inches in length and lives 3,000 feet below the waves. There's almost no oxygen there, but also relatively few predators. Whew, I think I'll need to decompress from this one.
The giant shark that terrorized the oceans some 20 million years ago. For 13 million years, this 60-ton beast dominated the warm waters of our planet. Though, some believe that the Meg still lives in the most remote and deepest parts of the ocean. It's a hot summer day. It seems only logical to go for a swim in the sea. You're floating on your back, completely relaxed. Your eyes are closed. Your breath is even. Water's pleasantly cool around your body. A light breeze touches your face. You feel calm enough to doze off. Suddenly, something bumps into your leg. Yanked out of your half-slumber, you begin to flail until you're face-to-face with the invisible danger. Luckily, all you spot is a couple of easily recognizable fins and cute smiley snouts. Phew, just dolphins. Guess you're lucky to meet them in the wild. These amazing creatures are so close, you can touch them. You've heard people say dolphins' skin feels rubbery, but to your mind, it's more like the inner part of a hard-boiled egg. One of the animals is so close to you that its salty smell fills your nostrils. You know, though, that dolphins don't have sweat glands. It means they don't sweat and are pretty much odorless. The smell you sense comes from the water they swim in. The largest and most ferocious predator to ever haunt the oceans, the megalodon shark dominated the seas for centuries before coming extinct millions of years ago. However, scientists managed to discover very few remnants of the giant shark. Everything we know about the great beast we've learned thanks to fossils of its giant teeth, which are just about the size of the average human hand. A megalodon skeleton has never been discovered. Shark skeletons are made mostly of cartilage, meaning that they decompose quickly. Luckily, sharks continuously shed and regrow teeth throughout their lives. One shark can go through 40,000 teeth in a single lifetime. Scientists have managed to study different types of shark species based on their teeth alone. The megalodon shark had around 276 teeth. When they fell out, those teeth landed in the seabed where they stayed for millions of years, fossilizing. Scientists found those teeth, and they're the only real record we have of the megalodon's existence. Megalodon teeth have been discovered all over the world. It means that unlike other marine animals of its time, the megalodon was intercontinental. Even today, most sharks and marine animals tend to stick to one sea or ocean. The megalodon shark swam freely around the world, moving between tropical and subtropical waters. Megalodon teeth have been found in every continent apart from the freezing cold waters of Antarctica. When a megalodon makes a starring appearance in a movie or TV show, it's portrayed to look like a giant version of a great white shark. Scientists previously believed that the megalodon and the great white shark both descended from one common ancestor. Still, it's not true. In fact, it's more likely that the megalodon was the arch-enemy of the great white shark's ancestor, the broad-toothed mako shark. That means megalodon wouldn't have looked so similar to the great white after all. In reality, the megalodon would have a shorter nose than the great white, along with longer pectoral fins to give the giant shark a stockier and more threatening build. They both had an excellent sense of smell though, so even in prehistoric times, it wasn't a good idea to go swimming with a chunk of raw meat in hand. And it certainly isn't safe now. Whether the Meg's hiding somewhere in the depths, which some still believe is true, or it's gone forever, younger cousins will still be there waiting. Also, both of them like to go after big marine mammals, so they would certainly have things to do together. That is, until the Meg got moody and accidentally ate its friend. You never know. These guys had a different hunting style. Great whites prefer to dive straight towards their prey and find its softest spot, like exposed legs or underbelly. Sometimes, an entire tooth would be found embedded in a bone of some bigger animal, such as a whale. Without the main parts they use for swimming, poor sea animals were then helpless and unable to escape. Yet whales were just a smaller part of megalodon's diet. Seals, sea cows, squids, dolphins, other sharks. The good old Meg probably wouldn't say no to some random school of smaller fish swimming into its mouth either. Nothing better than a good snack after a big tasty dinner. Even those giant turtles weren't safe with their thick shells. The Meg probably took them as a dare challenge on a daily basis. Scientists have used computer simulations to try and work out the hunting style of the ancient shark. Using this technology, scientists have discovered that the megalodon's attack style was very different from that of modern-day sharks. Modern sharks dive straight for their prey's most vulnerable spot, for example, the soft underbelly of a seal. The megalodon's teeth were uniquely suited to biting through tougher areas of cartilage. So, evidence suggests that a megalodon would first chew the tougher fins of their prey, rendering them unable to swim away before launching into their final attack. Some people believe that the megalodon is still alive today, lurking at the depths of the ocean's waters. But it's unlikely to be true. Megalodons are a warm water species, which means they would be unable to survive in the cold waters of the deep ocean. Most of the megalodon's potential prey live in shallower waters, meaning there would be very little for the megalodon to eat at deep sea level. Simply put, If there was an animal as big as the megalodon still living today, we would have spotted it by now. It is unlikely that you'll run into a meg though. The sharks, like us, preferred warm coastal waters. Deep ocean living would be too cold for the beasts, and food would be scarce. Their entire bodies would also have to evolve to avoid being squished by the enormous water pressure down there. It's unlikely they're still around, but not impossible. Some good news if you do run into one is that the shark is pretty unlikely to eat you. You are way too small a meal for the megalodon, even if you have a couple of friends with you. This guy eats whales that are over 50 feet long. If you're having a beach party though, it's a different story. In a beach full of swimmers, the shark very well might creep up, scooping several humans into its giant mouth without even chewing. The fearsome name megalodon comes from two Greek words, megas, meaning big, and odont, meaning tooth. Combined, they mean big tooth, and it certainly lives up to its name. Just one of its chompers is the same size as a human head. It had 276 humongous teeth in total, across 5 terrifying rows. In all of history, only a couple of saber-toothed cats and the T-Rex had consistently bigger teeth. Now that's a showdown I'd like to watch. The megalodon vanished millions of years ago, leaving only huge teeth to be found by modern archaeologists. They literally disappeared with very few traces left. Scientists believe that over time, deep sea levels dropped and the ocean's temperature went down rapidly. Over a third of all marine life was wiped out as the oceans cooled and the number of animals at the bottom of the food chain plummeted. This had a catastrophic effect on the hungry predators at the top. Sorry guys. It became way too cold for these sun-loving sharks too, which made it difficult for them to reproduce since they gave birth in warm waters. The megalodon is usually described as a sort of great white shark, but this is just a common myth. In fact, the ancestors of today's great white existed at the same time as the meg, but they weren't best buddies and were even in competition with each other. The great white shark was a better hunter using its smaller size and agility to snap up the meg's prey quickly. They were also known to eat meg pups, who were only half their size. This didn't exactly help the whole extinction thing. While a great white was no match for an adult meg in a head-to-head fight, they sure weren't scared of stealing their food. This only left the bigger fish and whales for the meg, but its food supplies began to run out as whales swam to the cooler new seas. The whales adapted to prefer the colder temperatures, leaving our friend the meg behind. The megalodons either starved or were frozen into extinction by the Ice Age. Rather than a great white, the megalodon is more like a modern bull shark. It had a short snout, a flat lower jaw, and huge pectoral fins to support its massive weight and size. As scary as they are, these sharks were actually caring family guys. Several megalodon nursery areas have been discovered in Florida, Maryland, and Panama. They gave birth to their young in shallow water environments. We know this from discovering loads of tiny megalodon teeth found in these areas. I wonder if they had nannies too.
Magma oceans, supersonic winds, scorching hot days, and instead of rain, a bunch of rocks falling on your head. Just another one of those days, huh? Astronomers recently discovered a new super planet out there. K2 414b is an exoplanet that's around 200 light-years away and in serious need of a new name. An exoplanet is just a fancy way of saying that a planet orbits its own star in another solar system. The Earth orbits the Sun, so this planet has its own orbit party going on. So what makes K2, bunch of numbers, so scary? Picture our beautiful little blue planet Earth. Now imagine that all the volcanoes in the world suddenly erupted at the same time and lava covered the oceans and seas. Fiery hurricanes, thousands of times faster than normal, blow all over the place, 24/7. And it starts raining rocks every now and again. Rocks, like on your head. Thankfully, not in your head. This scary planet came into our lives about 2 years ago. Scientists are still studying it. So, what's a typical day like? For starters, you can forget about breathing. Oxygen decided to take a pass on this planet. You'd have to get used to sodium, silicon monoxide, and silicon dioxide, which is, as you guessed, not great. And that's just scratching the surface. Who knows what other chemicals are lying around? And yes, magma oceans. The planet's surface is covered in molten magma as far as the eye can see. This lava planet orbits really close to its star, which is why the surface is like a fireplace. The closest planets to our Sun are Mercury and Venus, but this planet's even closer. And what's even more weird is that half the planet is in constant daytime, the other half night. It's tidal locked, just like our moon is. No matter how long you stare at it, you'll never see the other side. That's why the all-day, everyday scorching, fiery side is so hot and overflowing with magma oceans, while the other side's in a constant state of deep freeze. If the magma doesn't burn you, you've still got big problems, and please don't look up. It's raining rocks. On Earth, water turns to steam, rises up, becomes clouds, cools, and falls as rain. Over there, on planet Fireball, it's exactly the same, except for it's rocks, people. The planet's so hot, it vaporizes rocks. Oh, and don't forget the supersonic winds with speeds up to 3,000 miles per hour. Imagine your hat getting blown off your head at 5 times faster than an airplane. The strongest wind on Earth was the tropical cyclone Olivia that hit Australia. It was blowing at 250 miles per hour. Now imagine 12 times that. On the sunny side of the planet, you're looking at a roasting 5,000 degrees. The hottest it ever got on Earth's surface was in California, 135 degrees. It's pretty common for it to get near that temperature in the Sahara Desert, but that kind of heat's not exactly enough to make rocks evaporate. If you grew up near a desert, you already know how dry and hot it always is. But did you know that deserts can reach freezing temperatures? A desert, by definition, is a large area with little or no rainfall. That means no water vapor to keep the temperatures from going insane. In the daytime, the sun heats up the desert like an oven. But when the sun sets, the heat packs up and heads home, and it can get really cold. Some deserts have even reached minus 40 degrees at night. But wait, shouldn't deserts have snow if it's that cold? Well, some deserts have had a bit of snow here and there, but because there's no water vapor, there can't be that much snow. Just dry, freezing, sandy Sahara nights. Now, the Sahara Desert's actually not the largest desert on Earth. It's Antarctica. 5 million square miles of icy dryness, almost no people, and a whole bunch of cute penguins. Penguins technically live in a desert. Back to the Fireball planet, this time the night side. Never-ending darkness and extreme cold, about minus 330 degrees. Add in some supersonic winds? Earth's coldest? Minus 130 degrees at a research center in Antarctica. So, how does this jalapeno pepper exoplanet stack up against some of our neighbors? Well, Mars isn't exactly livable either. It's the red planet, so you'd think it'd be hot most of the time. But it's usually freezing, well, way below freezing. And if you're planning a weekend getaway to Mars, you can leave the umbrella at home. Nah, it doesn't rain rocks, and it actually hasn't rained there for millions of years. At least Mars has days and nights, and it's like Earth in other ways. Mars' equator is steamy hot, and it gets pretty cold at the north and south poles, just like Earth. Scientists even discovered old bits of carbon dioxide snow there. The entire planet is actually covered in carbon dioxide, with a splash of nitrogen here and there. Scientists even reported intense snowstorms on Mars. But because it's mostly carbon dioxide, it's not your typical snowstorm. It's more like a dry ice storm. That's the stuff they use in fog machines. Mars isn't the only place where climates are going cuckoo. Jupiter's famous for its gigantic storms. Not like the ones we know on Earth. I'm talking about storms that last for centuries. The Great Red Spot on Jupiter is actually a 400-year-old storm, and you could fit 4 whole Earths inside of it. So it's been around for a while, but it's nowhere near as intense as the storms on K2. Venus also has intense rain, but it's not made of rocks. It's sort of worse. It rains sulfuric acid. That stuff can give you severe skin burns and rip nasty holes through your umbrella. Venus's atmosphere is filled with carbon dioxide, which acts like a net to trap in the sun's radiation, and it's insanely hot. No magma oceans, though. Mercury is the closest planet to the sun and doesn't even have an atmosphere. That means no storms, clouds, rain, wind, whatever. Mercury is kind of like a desert here on Earth. No water vapor and no rainfall. That means temperatures shoot up during the day and drop like crazy at night. The K2 exoplanets, like the most extreme parts of all of our solar system, all rolled into one scary planet. But we're not headed there anytime soon. We haven't even been to Mars yet. That's all way off in the future, and 200 light years is a really long travel time. If we're going to move anywhere anytime soon, we'll probably want to set up camp on the moon. No magma oceans, no warp speed winds, nice temperatures. So, where would we even start? Well, the main issue is that drones and remote control robots are getting more and more advanced. It's way cheaper to send them over to map out the moon for us while we're safe here on Earth. And if we ever want to begin space exploration for real, we'd need a proper space base. And what better place than our little shiny moon? So, why do we even study those far-off planets? What's the point? Well, planets are like people. They're all different ages and live in all different places. The more of them we study, the more we can understand why there's life, aka us, on Earth and not on any other planet so far. When we see crazy new planets, we get crazy new ideas, which can turn into awesome inventions that make our lives easier. Even just going into space gives us new ideas. Scratch-proof lenses, some firefighting equipment, water filtration systems, wireless headsets, invisible braces, that tiny vacuum you use to clean those crumbs in from between your couch cushions, they were all invented to help astronauts work better in space. And now they make our lives better every day. Maybe we'll figure out a new energy source someday, thanks to a far-off planet or star. Or we might discover a new compound that will make our buildings stronger or more energy efficient. The Hubble Space Telescope was put into a low Earth orbit in 1990. If you think about it, it's had over 30 years of experience looking at various space objects. It was named after astronomer Edwin Hubble and was built by NASA. It is also part of a group of devices called NASA's Great Observatories, along with the Compton Gamma Ray Observatory, the Chandra X-ray Observatory, and the Spitzer Space Telescope. The Hubble Space Telescope was built to explore the universe and answer some of its biggest questions, such as how galaxies form and evolve, and how the universe itself has changed over time. The telescope has made many important discoveries, including providing evidence of the existence of dark matter and helping to determine the rate of expansion of the universe. One of the most famous images taken by the Hubble Space Telescope is the Pillars of Creation. It's a photo of a region of the Eagle Nebula, where new stars are born. The photo, which was taken in 1995, shows massive pillars of gas and dust towering above the nebula. It has become one of the most iconic images of the universe. The Hubble Space Telescope continues to operate and make important scientific discoveries, despite some initial technical difficulties. In 1993, a problem with the telescope's main mirror was discovered, which affected its ability to focus light properly. A repair mission was sent to the telescope in 1994 to fix the problem, and since then, the telescope has continued to work perfectly. One of the more interesting discoveries made by this amazing telescope is actually pretty recent. A report based on the data from the Hubble Space Telescope shows that there is a faint glow in space around the solar system that cannot be explained by anything we know to exist. Because they have yet to figure out the source, astronomers call this mysterious glow ghost light. We don't know that this light is not coming from the stars or galaxies near the solar system, nor is it coming from dust on the solar system's plane. The researchers aren't sure what the source of the light is, but they think it might be tiny particles of dust and ice left by comets. But it's only a theory that has not yet been confirmed. When we study the universe, we often find bright things like planets, stars, and galaxies. But from time to time, we discover some light coming from places where we didn't expect to see it, like from between planets. This light may be coming from deep within our solar system, and it may be a new phenomenon that hasn't been studied before. In other words, there may be something at the center of our galaxy that produces a lot of light. Spacecraft Voyager 1 also captured images showing a lot of light coming from the edge of our solar system. How come we haven't noticed this until now? Well, because most of the light in pictures taken by the Hubble telescope comes from things close to Earth. But people usually ignore this light because they're interested in things like stars and galaxies that are farther away. We've never actually looked closely at the amount of light in the universe and where it comes from. Scientists have been using the Hubble to find faint galaxies that may have been missed before and which may be the source of this dim glow. They found that there are not enough such galaxies to account for extra light in the sky. It's not a lot of light, though. It's like the glow from 10 fireflies. But it doesn't make it less important. It shows that we may be missing something. Let's look at some other important discoveries we've made with the help of Hubble. Like dark matter, which we can't see but know is there because of its effect on gravity. It makes up for about 23% of the universe. By looking at how it affects light, the Hubble telescope helped make 3D maps of where dark matter is. These maps show that dark matter seems to be getting clumpier over time, which means it behaves very similarly to how gravity does. The Hubble telescope also discovered 2 new moons around Pluto, named Nix and Hydra, and studied the dwarf planet's changing surface. Additionally, it's found the mass of planet Eris, which is larger than Pluto. This helps scientists realize there may be similar objects in the Kuiper Belt, a region outside our solar system. This led to Pluto being reclassified as a dwarf planet. Further observations of these distant objects could help us understand the evolution of our solar system. Gamma-ray bursts are the most powerful explosions in the universe, and for a long time, no one knew where they had been coming from. Hubble helped us find out that these bursts happen in galaxies, producing a lot of stars and having few heavy elements. This suggests that gamma-ray bursts happen when big stars collapse into black holes. These galaxies have lots of big stars that fall apart quickly, and the stars there don't have much heavy stuff, so they can turn into black holes. In 1994, the Shoemaker-Levy 9 comet collided with Jupiter. Hubble captured the whole event in detail, like a resourceful journalist. The impact broke the comet into a lot of small pieces, which resulted in 21 other visible collisions. The largest impact created a fireball and a dark spot on Jupiter's surface. Hubble's observations not only sparked public interest in cosmic impacts, but also provided new insights into Jupiter's atmosphere. To move forward with our list of discoveries made by the Hubble telescope, we also need to talk about black holes. There are points in space where gravity has so much force that even light cannot escape it. The gravity becomes so strong that matter gets squeezed into a very small space. We know that this can happen when a star, like the Sun, nears the end of its life. At the beginning of its life, a star's hydrogen ignites in its dense hot core. Because of gravity, it tries to draw its own mass into a tiny point. As long as it has the energy generated by the hydrogen fusion, it also pushes outward. If we look at it this way, the life of a star depends on a delicate balance between these forces, and it can last millions or even billions of years. Once that energy is exhausted, the only force remaining is that of gravity. So, some stars become black holes. Since light itself cannot escape its pull, we can't visualize black holes. For the human eye, they are invisible. We need special tools and unique telescopes to help us point them out in the universe. Hubble found that most galaxies with a central bulge of stars likely have supermassive black holes. It also noticed a strong connection between the size of these black holes and their host galaxies, which might help us understand how the universe has changed over time. Then, what is a supermassive black hole, you might ask? Go ahead, ask it. It is a very large black hole that is typically found at the center of a galaxy. It is millions or even billions of times more massive than our Sun. These black holes are so powerful that they can swallow stars and even entire galaxies. Scientists are still exploring these mysterious objects, but they believe that they play a crucial role in the formation and evolution of galaxies. Now, before Hubble, we really didn't know how old the universe was. It often led to weird paradoxes, like the one where stars discovered by astronomers were older than the universe itself. But by figuring out the approximate rate at which the universe is expanding, Hubble helped us narrow down its age, which is about 13.75 billion years. Trying to figure out the exact age of the universe is an important question. That's because most astronomers think that the universe has not existed forever, but appeared in one really hot and dense fireball called the Big Bang. I wasn't around then.
You wake up with a start, feeling disoriented. You were dreaming of waterfalls and green fields just a moment ago, but now your body is tingling weirdly. It feels as if you don't have enough oxygen to breathe, which makes you panic a bit. You open your eyes and look around. Oh, you're inside your sleeping capsule. Whew! Its walls are littered with different buttons and tiny screens. You press one of them, and one of the sliding panels sweeps to the side. You crawl out of your pod. The absence of your windows or any natural lighting makes you feel as if you're underground. Dozens of sleeping capsules line the walls. The door leading out of the dorm is made of metal. It looks heavy and unmovable. But once you press the button on the wall next to it, the door opens smoothly and soundlessly. After walking up a dimly lit corridor for a while, you find yourself in a smaller room. There's at least half a dozen bulky spacesuits inside. There's another door in the room. It looks even sturdier than the previous one. If you wanted to open it, it wouldn't budge. First, you need to put on one of the spacesuits. As soon as it's on, the door automatically unlocks. After waiting for a while in an airlock chamber, you finally make a step outside. You look up and see a beautiful blue orb. It seems to be glowing. It's Earth, and you're standing near your home base on the moon. You walk towards your Jeep. It looks nothing like cars on Earth, though. The vehicle you climb into is pressurized, and you can even take off your spacesuit, or at least your helmet, and ride in comfort. If you need to go outside, well, yes, you can't do it without wearing your protective gear. One of your favorite rovers, produced by Toyota, is the size of 2 microbuses and can easily fit 2 passengers and their gear. Of course, you've got the experience of riding it with 3 other companions, but duh, you were squashed like sardines that time. The vehicle can also unfurl solar panels to generate power. After dealing with all the tasks you had on your list, you come back to your lunar home. Unlike your house on Earth, it looks more like a castle. Due to the extreme temperatures on the moon, the lack of oxygen, the constant threat of meteorites, and the never-ending barrage of radiation from the sun, it has to be super sturdy. The thing is, on Earth, we're protected by the atmosphere. Most meteorites burn while passing through it, and it also protects Earthlings from harmful ultraviolet radiation and creates the pressure without which liquid water couldn't exist on the surface of the planet. On the moon, there's no atmosphere like that. The very weak one that exists on our natural satellite is made up of some unusual gases that haven't been found in the atmospheres of Earth, Mars, or Venus. That's why people living on the moon have to take care of these issues themselves. The first towns on the moon were built in craters and covered with protective materials, like plastic reinforced with a net made of titanium and UV-resistant superfiber. The inhabitants had to access their homes through airlock entrances dug into a mound. Bilbo Baggins would surely appreciate their aesthetics. On the moon, gravity is way weaker than on our home planet. And while it makes it easier for you to walk and even run on the satellite surface, even despite your bulky spacesuit, it's not great in the long run. That's why inside lunar bases, there's an artificial gravitational field. Without it, people would have problems with coordination, balance, and orientation in space. Plus, weight-bearing bones would lose 1% to 1.5% of mineral density per month. And there would be many other problems with health. Anyway, these days, along with old settlements located in craters, there are new towns that look like transparent glass spheres. They make a beautiful picture when you look at them while approaching the moon after visiting your family on Earth. Next to many of these domes, you can spot tall sun-reflecting towers. They can simulate the day cycle to help human bodies function properly, as they used to be on our home planet. Inside, there's a breathable atmosphere and fixed atmospheric pressure. The floors look as if they're made from regular concrete, but the material used in the construction is lunar dust. A colony on Mars would cost us trillions of dollars to construct and inhabit. It would take a long time for even one cargo ship to reach the red planet. But lunar towns are much easier to build and maintain. There are direct spaceship routes connecting the satellite with Earth. And you need just 3 days to travel between these 2 points. That's one of the reasons the colonies on the moon are growing, developing, and changing non-stop. When people first came to the moon with the intention of building settlements, their main concerns were producing energy and getting oxygen and water for a comfortable life. Now, you have trash can-sized nuclear reactors that provide the towns on the moon's surface with steady power. Plus, in some regions of the satellite, for example near the South Pole, there is near constant sunlight, which is great for getting solar power. That's one of the reasons why most lunar settlements are built in that area. Another thing that makes colonizing the moon easier is its ice. People living on the satellite use it to make hydrogen-oxygen rocket propellant. The main way to get the raw material is by using the regolith and ice drill for the exploration of new terrains. That's a piece of equipment designed for drilling in ice-cemented regolith and rock. This fuel is then used for cargo and passenger ships coursing between Earth and the Moon. Right now, people are trying to derive oxygen and other useful products from lunar soil. More than 40% of the lunar crust is composed of oxygen. Of course, it's bound up in minerals in combination with other elements. These compounds are called oxides. You might have heard of quartz, aka silicon dioxide. It's the second most common mineral in Earth's crust. To move from one lunar town to another, you use moon Ubers, taxiing people and cargo. They're also called all-terrain hex-limbed extraterrestrial explorers, or athletes. They have 6 limbs that can grip cargo and roll or step over obstacles. Plus, they can switch out quick connect gripping and digging tools if you need them. They also carry people to and from launch pads, acting as lunar airport shuttles. But lunar towns aren't just placed where people live. They're innovative research hubs both for industry and science. They're also a popular tourist destination. Plus, people living there are tirelessly working on developing and constructing a special base for future Mars missions and the exploration of distant space. But let's have a look at how it all started. For instance, how the first lunar bases were built. Private landers descended on the surface of the moon and deployed inflatable modules, each around 4 stories tall. They served as residential areas, workspaces, industrial sites, and scientific labs. But those modules couldn't completely protect their inhabitants from harmful radiation, temperature swings, and the strikes of micrometeorites. So, people developed robots that could 3D print protective shells around each inflatable module. They used readily available regolith taken from the surface of the moon. It took the robots about 3 Earth months to finish solid domes. Some of these settlements were later connected with one another through a series of walkways linked to airlocks in each dome. At the same time, some of the towns remained separated, like those constructed in craters. When you visit Earth, you often look up at the sky, searching for your new home. Some of the lunar bases are visible if you're looking at them through a telescope. Others, partially hidden underground or covered with lunar rocks and soil for better protection, are almost impossible to spot.
Now, we all know that all planets are round. There are no square ones so far, and that's because of gravity. Well, roundish at least, as not all of the planets have perfect proportions. But did you ever wonder about the shape of the universe itself? Is it also round because of the same forces? Well, not really. Based on what information we have so far, the universe is actually flat? According to the principles of general relativity, space has the ability to curve. This opens the door for the universe to have three potential shapes: a flat plane like a sheet of paper, a closed sphere like a bowl, or an open saddle-like curve. This isn't just a matter of academic interest, you know. The universe's shape has direct consequences on its ultimate destiny. One cosmologist from Princeton University explained it beautifully. The shape of the universe is a kind of map to its past and a predictor of its future. The questions of whether the universe will keep expanding forever or collapse at some point, and if it's finite or infinite, all circle back to the question of its shape. Now, to wrap your head around this cosmic question, you need to understand two key elements: the density of the universe and its rate of expansion. Let's dig into this a little. Around 68% of the universe is made up of dark energy, while 27% is dark matter. The rest, which is normal matter, if you'd like, makes up the stars, planets, and other cosmic bodies we're familiar with. When we talk about the density of the universe, we're referring to the quantity of normal matter packed into a given volume of space. Now, if the universe is denser, it also has more gravity. In this case, the gravitational pull can overcome the force of expansion, so the universe curls up into a sphere. This shape is known as the closed model, where the universe ends up looking like a gigantic cosmic ball. Imagine a world that's finite but without boundaries, a contradiction for sure. In this model, an adventurous explorer could travel forever through space, never bumping into a wall or falling over an edge. Alternatively, if the density of the universe is low and not enough to halt the expansion, then space distorts in the opposite direction. This results in an open universe with negative curvature that resembles a saddle, like on a horse. Despite these two potential scenarios, most scientists agree that the density of the universe is just right, which means it expands proportionally without curving. But what does it mean if the universe is flat? It doesn't mean we're living in an infinite sheet of paper. To understand it, consider these analogies. Imagine you're in a square room, walk 10 steps to the next corner, make a 90-degree turn, walk another 10 steps, and repeat this process twice more. You end up back at your starting point, completing a square. Add another dimension to this geometry, since we're not 2D creatures, and whoopee, you have a flat universe. This analogy wouldn't hold up in a curved space. If you have a terrestrial globe at home, you might find it easier to understand this next experiment. Start by placing your finger at the Earth's equator, then trace a line to the North Pole, make a 90-degree turn, and return to the equator. Make one more 90-degree turn and walk back to your starting point. This journey only needed 3 turns, unlike the 4 turns in the flat universe scenario. Still struggling to understand? Here's another way to picture it. In a flat universe, 2 rockets traveling side by side will always remain parallel. This is in contrast to a closed universe, where the rockets will travel along the curve of space and eventually meet where they started. In an open universe with negative curvature, the rockets will gradually drift apart and never cross paths again. So, is there a cosmological crisis at hand? It seems the answer to the shape of our universe is encoded in the cosmic microwave background, also named CMB, which is like the universe's fossil record. Over the past few decades, scientists have measured temperature fluctuations in the CMB to find almost no curvature, indicating a flat universe. Now, the concept of a flat universe is crucial to the standard cosmological model. However, in late 2019, scientists from a university in Rome published a paper arguing that current CMB measurements actually indicate we're really living in a closed universe. How did they figure this out? Well, they looked at how light behaves in the universe. Specifically, they analyzed how light bends because of the gravitational force of matter in its path. Either way, apart from this finding, there's nothing else that would suggest we're living in a closed universe. Most scientists believe this recent discovery is nothing more than a statistical anomaly. But if the closed universe theory turns out to be right, it would shift decades of astronomical findings. If the universe is indeed curved, it must be so large that the observable 93 billion light-years aren't enough to reveal its curvature. It could be similar to standing in a fog, only able to see a small, flat patch of land. Yet somewhere out of sight, the horizon reveals that we live on a sphere. As we continue to probe the cosmos, we might find that the apparent flatness of our universe is just a small part of a much larger, curved cosmos. Its shape is just one of the many things we've yet to figure out about the universe. We can't quite put our finger on why the universe is even here, for instance. We do have some theories, but scientists are yet to be sure. It could be that the universe is like a pop-up, materializing out of an unstable nowhere land. Imagine the emptiest emptiness you can think of, suddenly churning out matter and energy in equal and opposite amounts that tally up to zero. For most of us, it's hard to picture that process. If we follow this theory, who's to say there's only one universe? We might be just one of an enormous collection, a so-called multiverse. For now, we'll just have to wait for the next wave of cosmic measurements to refine our theories, and for scientists to come up with hypotheses that aren't just mathematically pretty, but actually testable. Also, how could we possibly know all the secrets of the universe if we don't completely understand our own biology yet? I mean, if we did, we could, theoretically, solve all of our health problems, right? We might even be able to play around with our DNA, like this molecular Lego, and give ourselves naturally purple hair or red fingernails. Well, time for a reality check, as we're still struggling with this one too. Here's a great example: our microbiome. Our bodies, home to 10 trillion human cells, are also an active city for 100 trillion microbial cells. That's a couple of pounds of bacteria and other microbes, which we absolutely can't do without. They've set up shop in our bellies, lungs, noses, and every other hidden nook and cranny. We're like luxurious cruise ships for these tiny microbial tourists, and we still don't fully understand the implications of this symbiotic relationship. There are still a lot of things we don't know about planet Earth either. We've only ever dipped our toes into Earth's crust, never venturing more than a few miles deep. Everything else is our best guess, from remote sensing and smart physics. Believe it or not, it took us an embarrassingly long time to accept that the Earth's crust is constantly shifting, like Jenga pieces. We only warmed up to plate tectonics in the mid-20th century. We're also still trying to figure out precisely how the planet's inner engine works, and how the swirling conducting materials in the outer core create our protective magnetic field. Plus, with 4.5 billion years of geological chaos, we're sometimes better off studying meteorites or the surfaces of other celestial bodies for clues about our planet's history. Even our faithful companion, the Moon, is a bit of a mystery. Was it born from a colossal collision or some other event? We're still not sure. But hey, the fact that we still have a lot to learn is what makes life interesting, isn't it? That, and the thrill of actually finding an empty parking spot in San Francisco, or maybe even your city.